essentially have three vectors here, vector A, vector B, and vector C. And we can find the x and y components of each vector. So we have A sub x, B sub x, C sub x, then we have A sub y, B sub y, C sub y. And all of these are going to be solved with trigonometry, where we can say the magnitude of vector A times the x component of vector A would be the magnitude of component of vector A times cosine of 30 degrees. The x component of vector B would be the magnitude of vector B times cosine of 110 degrees. And the same thing for C times cosine of 180 degrees. And we are using the exact same formulas for the y component. However, instead of cosine, we're using sine. So this would be A sine of 30 degrees, B sine of 110 degrees, and then C sine of 180 degrees. So the x component of vector A would be equaling positive 152 kilometers. X component of vector B, negative 51.3 kilometers. Then we have negative 190 kilometers for the x component of vector C. Vector A, the y component, 87.5 kilometers. The y component of vector B, 141 kilometers. And for vector C, the y component would simply be 0. And so we find that the x component of the resultant vector is simply equal to the sum of all the x components. And this is equaling negative 89.3 kilometers. And then we have the y component of the resultant vector, the sum of all the y components. This is equaling 229 kilometers. And then the magnitude of the resultant vector would be equaling the square root of the x component of the resultant vector squared plus the y component squared. And this is equaling 246 kilometers. We can find an angle theta. This would be equaling arctan of the y component divided by the x component. So essentially r sub x 89.3 divided, my apologies, 229 divided by 89.3. And this is giving us 21.3 degrees. Now we have a negative x component and a positive y. So this would be 21.3 degrees, and we have a higher component in the y direction than in the x direction. So this is actually 21.3 degrees west of north. This would be our final answer for the direction. And then our magnitude of the resultant vector, 246 kilometers. This would be your final answer. That is the end of the solution. Thank you for watching.